Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on bilinear and impulse invariant transformation in IIR filter design. See empathy, why bilinear transformation? See digital IIR filters is of analog filters, well understood foundation for digital filter design. Stability ensures reliable and predictable filter performance. No aliasing prevents signal distortion in signal conversion. Prototype conversion transforms analog designs into digital implementations. Next one, why impulse invariant method? First, we can preserve the time domain, ensures the digital filter, maintains the original analog filter time domain characteristics. Simple implementation offers a straightforward approach for converting the filter, and tolerance aliasing suitable when aliasing effects are minimal or acceptable. Next one, IAR filters generate impulse response, design filters, process signals and analyze the output. The filters designed by considering all the infinite samples of impulse response is called as in IAR filters. Next one, frequency response of analog IAR filters. It can be classified into low pass filter, high pass filter, band pass filter and band stop filter. Low pass filter allows frequencies below a cutoff point to pass through while attenuating higher frequencies. High pass filter allows frequencies above a cutoff point to pass while attenuating lower frequencies. Band pass filter allows a specific range of frequencies to pass through while attenuating frequencies outside this range. Band stop filter attenuates a specific range of frequencies while allowing frequencies outside this range to pass through. Next one, define bilinear transformation. Bilinear transformation is a conformal mapping that transforms the imaginary axis of S-plane into the unit circle in the Z-plane. It is a one-to-one mapping. T is nothing but sampling time period. S is equal to 2 by T into 1 minus Z inverse divided by 1 plus Z inverse. Next one, this is the bilinear transformation of S-plane into Z-plane. The left half of S-plane are mapped into the unit circle, interior of the unit circle in the Z-plane. The right half of S-plane are mapped into the exterior of the unit circle in the Z-plane. Next one, impulse invariant transformation. The objective of impulse invariant transformation is to develop an IAR filter transfer function whose impulse response is the sampled version of impulse response of the analog filter. Transfer function of analog filter h of s is equal to Laplace transform of h of t. It can be defined as 1 divided by s plus p suffix k is equal to 1 divided by 1 minus e power minus pk into t into z inverse. T is nothing but sampling time period. Next one, this is the impulse invariant transformation from S-plane to Z-plane. The left half of S-plane are mapped into the interior of the unit circle in the Z-plane. The right half of S-plane are mapped into the exterior of the unit circle in the Z-plane. Next one, these are the steps involved in bilinear transformation. First, specify the requirements, pre-warp the frequencies, adjust critical frequencies to compensate for distortion, design analog filter to meet the specified requirements, apply transformation for conversion of analog filter into digital filter, obtain transfer function, decide the digital transfer function that describe the filter's behavior. Next one, steps to find the impulse invariant method, right? Design analog IER filter, find the analog impulse response and then sample impulse response, obtain the digital impulse response, compute digital transfer function. These are the reflection and innovation of bilinear transformation and impulse invariant transformation. First, no aliasing eliminates unwanted signal distortion in digital signal processing. Stability ensures reliable and consistent signal processing outcomes. Frequency warping alters frequency response affecting signal characteristics. And it is used in digital audio filters enhance audio quality by filtering specific frequencies. Communication systems facilitates clear and efficient signal transmission. Next one, this is the mind map of bilinear transformation. It can be defined as IER filters, infinite impulse response, types of low pass, high pass, and band stop. Advantages, no aliasing, preserves stability, predictable performance. Limitations, frequency warping, applications used in digital audio filters and communication systems. Next one, this is the mind map of impulse invariant method. It is of overview of IER filter design, analog to digital conversion, preserve time domain characteristics. Design steps. First we can design the IER filter, find analog impulse response, sample the impulse response of the filter, obtain digital impulse response, compute digital transfer function. Filter classifications of low pass, high pass, band pass and band stop. It is of applications. It is used in digital low pass filter, control systems and signal analysis. Next, now we can see the assessment. What is mean by AR filter? The filter designed by considering all the infinite samples of impulse response is called as IER filter. Bilinear transformation is the one-to-one mapping. Transfer function of analog filter, Laplace transform of h of t is equal to h of s. Based on the frequency response of the filters, they are classified into four basic types. They are low pass, high pass, band pass and band stop. Define impulse invariant method. Impulse invariant method can be defined as 1 divided by 1 minus e power minus pk into t into z inverse. List the steps involved to compute bilinear transformation. See, bilinear transformation, first we can find out the analog transfer function and we can apply the transformation whether it can be bilinear or impulse invariant, and finally obtain the transfer function of the IER filter. Thank you.